is velocity, A is the area, right? So for our case, we have AU, okay, because we are component velocity in U direction. Okay. So the area will become U, the change of area. So what we do is when we calculate, we need to analyze from 0 to the height, which is B. Okay. This one must be corrected. Attachment tu kita letak dekat bawah kan. This is X and this one is Y. Okay, let's go to the equation. So Q equals to from 0 to B U D A. Right, so 0 to B, U is what? The one that we have found the other day. 1 over 2 mu del P over del X Y squared minus BY. Okay, DA. Okay, the change of area. So why we do this, the change of area? Basically what we want is we are going to change this in terms of dy. Okay, 1 over 2 mu del P over del X Y squared minus BY W dy. Because Y is at any position of Y from 0 to B. So our equation is valid from for any range of height of B. B over 2, B over 4, B over 5 for example. Okay. So what is W? W is the width. Kalau kat sini ni lah panjang ni. Width. So this is W. dy is this height. Kalau saya besarkan, okay, kita bagi ni. Okay, kat sini lah. So katalah saya besarkan yang ini ke sini. So this is the plate. Okay, so the height is yang ini height. Okay, so yang ini adalah dy, whereas yang ni for this one is actually the width. So area would be this one. This is the area. And this is the direction of Q, Q direction. Right? So we are going to solve this equation. So this one equals to whatever constant you have from this part, you can put it to the right. So it's become what? W is constant, right? So W divided by 2 mu del P over del X from 0 to B. Okay, Y squared minus BY dy. Okay, So sekarang you solve kan, integrate this one. Right, cuba buat integrate y squared minus by and then solve in terms of b and kosong lah, from 0 to b. Okay. Right, siapa dah dapat?
Dapat B kuasa 3/3 tolak B kuasa 3/2.
B kuasa 3/3 tolak B kuasa 2
B kuasa 3 B kuasa 3
Okay.
over 2.
Okay, alright. Cuba tengok Yang lain dapat berapa?
Sama je.
Sama Okay, so kita tengok. So W over 2 mu del P over del X. So from 0 to B. So yang ni akan jadi Y kuasa 3/3. And then BY kuasa 2/2 lah. Okay, and 0 to B. Betul?
Betul.
Okay, so W over 2 mu del P over del X. Okay, ini akan memasukkan B So B kuasa 3/3. And then B squared over 2. Okay, so minus kosong lah kat sini kan. Kosong. Okay, so in the end kita boleh ringkaskan dia. So berapa jadi ni? Equals 1/2 mu del P over del X. So bawah ni semua boleh jadikan 6 kan. 6. So B cube minus B cube. So negative B cube. Betul?
Betul.
Betul.
Alright, semua dapat And then what we get is 1 over 12 mu. Okay, del P over del X B cube. Right. So that is the answer. Negative. Negative. Sebab ni ada negatif di sini. Okay, ada soalan? Oh, senyap kan? Okay semua?
Okay.
Okay. Alright. Okay, so sekarang ni ni tak, we have not done yet actually. Okay, but in terms of expression tu, we have solved the expression. But basically what we have here is the del P over del X. Okay, del P over del X. So we're gonna solve this one. Okay. Why? Because of later when we are going to put the values, del P over del X does not mean anything. Okay. So we're gonna solve it. Put the equation that can be substituted by value. Alright. So we are gonna proceed. So in terms of expression, certain. Now, if you want to have the actual value, we need to proceed with this. So you're gonna have your Q equals to 1 over 12 mu negative. Okay. So for this one is del P over del X is equals to delta P over L. Change of pressure to the L. L is the length of the plate. Okay. So delta P is P out minus P in. The change of something doesn't matter. Pressure ke, mass ke, for example. Okay. Anything. Okay. Always yang downstream minus the upstream. Okay. So for this case, downstream is P out and P in is the upstream. So divided by length. So P out minus P in divided by length. So P cube W. So that is Q. Right. So from here on, now we can put the value. Okay, 1 over 12 multiply with what? What is the value? Masukkan value yang dibagi tu. Okay, berapa dapat?
Sir, nilai 0.015 dengan 0.8 tu dapat mana, sir?
0.0018. Sorry, tulisan saya ni kan. 0.0018. Tulisan plus pen. Okay, dah lama tak tulis kat sini. Alright. B is 1.8 meter, 1.8 millimeter. Right? So yang ni B cube lah ni. B cube. Kosong 0.8 is the width of the plate. 0.8. Okay, so berapa dapat?
Kosong 0.2979.
0.2979 meter cube per second. Ke?
Ya.
Okay, kawan lain berapa dapat?
Kenapa saya dapat 5.36 darab 10 kuasa negatif 4?
Kenapa Rabia tu dapat 5.36 darab 10 kuasa negatif 4? Okay, how about yang lain?
Saya dapat macam Rabiatul sih.
Syakira pun dapat macam Rabia tu. Muhammad Alimi
Sama macam Rabiatul.
pun sama macam Rabia tu. Irsyad. Irsyad ada Irsyad. Mike, kalau Mike rosak boleh tulis dekat chat lah. Irsyad 165.52. Okey. Muhammad Azim. Muhammad Ashraf. Ada? Kan. Silap jawapan kan. Okay, so jawapannya betul lah. Sama dengan yang kawan kita tadi tu. 5.36 10 cm 4. Meter.
Sorry sir, saya tertekan keluar tadi terus.
Oh, tak apa. Azim Azim dapat berapa?
Dapat 5.36 kuasa 10 negatif 4.
Alright, okay. Okay, so this is the answer. Okay, meter cube per Second. So kalau you notice kan, yang tadi tu just expression. Okay, let's see. Determine the equation of velocity profile and the volume flow rate. So untuk yang case volume flow rate ni memang memerlukan jawapan yang inilah. Okay, which is the expression. Okay, even kalau you put out this term also become an expression, also become jawapan. Cuma please point out lah, that is your answer for this question, because they want equation. Determine the equation of V and Q. Okay, so buatlah macam ni, ada garis, lepas tu ada solution. Mungkin nombor 2 lah, flow rate for example. Because if you just answer without pointing out what is your answer for that question, we don't know whether you understand or not. Okay. So this is the answer for if they ask for value. Okay. Okay, next is determine the Reynolds number. So in terms of Reynolds number, since you already have the value, Q this value, right? So RE. First is this. You already have Q, right? So B is actually Q divided by area. So for this case, 5.36 times 10 to power negative 4 divided by B is what? B is berapa tadi? 0.0018. Height, the width is 1.8. Okay, 1.8. Calculate. So you need to get your V. So next, for you to calculate Reynolds number, RE equals to rho VB divided by mu. Okay. So rho is given, right? Berapa tu? 865. Okay. 865. V after you calculate just now, kena calculate and then B is 0.0018. Mu berapa tadi? 72.5 times 10 to the power of negative 3. Okay, so this is the Reynolds number value. Okay, so you just calculate, but I want to point it out further. Let's say, saya padam ni. Okay, stop kat sini. Okay, let's say if they ask for expression. Contoh, they ask for expression V. Expression of V. So, now V become Q apa tadi? Q negative 1/12 mu. Let's say you use yang del P over del X tu. Tak ada masalah kalau you guna P out minus P in divided by L pun tak ada masalah. P cube divided multiply with W. Now, area adalah BW. Okay, so cancel. Allah Allah. Cancel. Cancel. So ni jadi B squared lah. Cancel ni jadi 2. So, negatives 1/12 mu del P over del X B squared. So this is in term of expression. Yang to the left tu is actually in terms of actual calculation. Students selalu silap yang ni. Okay. Soalan yang ni, dia nak equation hanya 2 sahaja. In terms of expression lah. Dia nak velocity profile and Q. Right? So kita dah dapat expression. But let's say dia nak tanya lagi satu, velocity pun dalam in terms of expression. Okay, so you boleh buat yang ni. Okay, again sama juga macam Reynolds number. So Reynolds number tadi dah ada kan, E equals to rho P tadi berapa, that value lah. Okay, rho multiply with negative 1/12 mu del P over del X B squared. Okay, negative 1/12 mu del P over del X B squared. Okay, apa lagi? Ada B lagi satu. And after that, mu. Okay, so you solvekan this one, you akan dapat negative rho divided by 12 mu squared del P over del X B cube. So this is Reynolds number in terms of expression. Yang belah kiri, Reynolds number in terms of actual calculation. Sometimes they ask everything in terms of equation or expression, but sometimes they mix up. Okay, sebahagiannya adalah expression, sebahagiannya adalah actual calculation. For example, this case. Kan? So keyword dia kalau dia calculate value. If other than that, equation, expression, so it means they ask for symbol. Alright? Clear tak apa yang saya explain dekat sini?
Clear, sir.
Sir. Sir. Sir.
Saya ada. PowerPoint tu juga.
Boleh tak saya ulang balik pasal yang untuk expression Reynolds number ni, tak faham tak?
Apa yang awak tak faham?
Yang expression ni kena guna time bila?
Expression ni, if they ask for equation. Okay. Kita tengok balik kat soalan Alright. Penting ni. Yang tak penting. Okay. Assuming the oil is as an incompressible, steady and fully developed amino flow of viscous fluid, determine the equation for velocity profile, volume flow rate and Reynolds number. Nampak tu? Kita tambah lagi Reynolds number. Determine equation untuk velocity profile, untuk flow rate, untuk Reynolds number. Okay. So, untuk soalan yang ini sebenarnya yang bahagian ni lah dia minta. Okay, soalan yang sebenar dia nak value Q. Kita memerlukan value V. Kita memerlukan value V dengan value Q, actual value. Sebab later kita nak calculate actual Reynolds number. Sebab dia suruh calculate. So we need to calculate Q, we need to calculate V, and then after that we need to calculate Reynolds number lah. Okay, we need those two for to calculate Reynolds number. Dia saja dia tambah kat sini. Okay. Katalah soalan tu dia tak nak calculate, dia nak determine equation of velocity profile, volume flow rate, and Reynolds number. So it means dia nak expression sahaja, dia tak nak actual value. Sometimes they put out value here in the equation. Dia saja letak mu, rho, for example, P in 100 kPa. But in actual, dia tak nak. Dia hanya nak expression. So, jawapan yang itu, yang ni lah. Itu jawapan dia. Dia ada one value.
Okay, faham. So kiranya je depend on question lah. If dia nak expression, just bagi yang belah kanan je lah.
Ya, betul.
Alright. Okay, sir.
Okay. Yang menu dia penting sebab soalan ni they play with that terms lah. Okay, because engineers as important expression. Why? Because let's say any flat plate that have this case P in, P out, B height, fixed plate, dia punya expression dia sama saja. Tak kisahlah macam mana bentuk flat plate tu masuk. I mean the dimension of flat plate doesn't matter. If B now become 2 meter, and then after that width become 1.8 meter. So if you have the expression, we just put out the value later, right? So we as an engineers, contohlah if you buat projek ni untuk kereta Azora lah katakan, Proton Azora. Kalau you calculate actual Proton Azora punya value, terus dia keluar value. In the end, bila you pergi projek Proton Wira lah katakan, Proton lain, you kena calculate balik. Sedangkan dua-dua tu menggunakan dua-dua tu menggunakan sistem yang hampir sama. Fixed plate, P in, P out ada, tak ada gravitational effect, flow from left to right, for example. X and Y positioning is at the bottom. Okay. So, bila you bagi expression, settle kat projek kereta Azora, contoh, you dapatlah Reynolds number ni. RE negative P, negative rho, negative 12 mu squared del P over del X B cube. Dekat kereta Azora. Bila you pergi dekat projek kereta Wira, for example, pergi pula ke projek lain, you lead projek lain pula, you can use the same expression. Now density dekat Azora 1000 kg per meter cube, dekat Wira dia pakai oil, for example, you tukar sajalah 998. So that is basically why expression is important as an engineer. So that's why question tu selalunya akan keluar expression. Dia tak nak tanya value. Okay, faham semua?
Faham?
Alright. Okay. So next we go to what? Okay, saya nak explain this one. Boleh explain lagi Kalau you tengok soalan ni X and Y kat sini tau. Okay, so your what we solve here now is this one. So you have fixed plate. And you have X and Y. Okay. And then yang kita solve dekat sini, saya tukar ni lah. Yang kali biru lah. Okay. Allah. Fixed plate. So this is X, this is Y. The one that we solve is actually this one, X and Y. The height is still maintained B. Okay, and this one is the what? The floor. Okay, the floor. So you have what? BC1 and BC2. Bawah BC1, for example. BC1. And this one is BC number 2. Okay. So untuk color merah ni adalah yang kat bawah ni. The origin is actually positioned at the bottom. Okay. So for BC1 is what? At Y equals to 0. And then you have U equals to 0. Because our velocity is U. And the change of U towards Y is not equals to 0. So that is BC1. Meanwhile, BC2 akan jadi at Y equals to B, U equals to 0. Okay. So, soalan exam tu sebenarnya bukan position yang tu. Tapi saya ajar yang bawah dulu lah. So, nak bagi you faham kan. So, in the exam question, if you notice, X and Y position is actually at the top side. So X is actually at the top plate and Y to the from that origin upward. So saya tukarlah color purple. Okay. So BC1 now become what? Dia kan ada perbezaan tak sama. So at Y equals to berapa? Nur Irisalina ada?
Ada sir.
What do you think? At Y equals to? Untuk yang purple color tu, color yang purple, bila origin dia dekat atas.
Y equal to zero.
Kalau Y equals to 0, you masukkanlah dekat yang top plate. Okay, so Y ni sekarang ni position dekat sini tau. This position. So Y 0 kat sini. Kita Salina. So sekarang Y tu menghala ke atas, B ke bawah. So sekarang kita nak sekarang BC1.
-1/2B.
-1/2B. Continue ke bawah lagi kan?
Oh.
Ke sini. Sampai sini. Berapa tinggi ni?
B tinggi dia 1.
Y ke atas.
Y.
So Y equals to B ke bawah. Kalau ke bawah,
Negative B.
ya. Betul. So at Y equals to negative B now sekarang. So at Y equals to negative B, U equals to berapa?
Zero.
Ya, betul. Okay, at Y equals to negative B, U equals to 0. Okay, thank you. Okay. So BC2 sekarang berapa? Sekarang ni BC2 dekat atas. Dekat atas BC2. Cuma kita buat yang purple color lah. Origin yang XY ni. So BC2 sekarang ni akan jadi at Y equals to 0. Because Y is positioned in this, at the top plate is the origin. So we meant for this position and titik tu kan. So at that position Y sama dengan kosong. So still U sama dengan kosong. So let's go for BC3. Okay, BC3. So BC3. Okay. Now untuk yang red color ni means untuk origin yang merah ni lah. At Y equals to B over 2 like what we did before. And del U over del Y sama dengan kosong. Saya dah explain kenapa dia del U over del Y sama dengan kosong. So untuk case yang BC3 untuk origin yang purple color ni, top ni BC3. Now at Y equals to, siapa boleh dapat?
Negative B over 2.
Ya, betul Danish. Pandai. Okay. Y equals to now become negative P over 2. And then del U over del Y masih lagi sama lah kan. So you nampak, can you see the difference between both equation? I mean both boundary condition.
Saya nak tanya sah.
Yeah.
Sekali. Saya tak faham. Untuk boundary condition 3 kan, du over dy equals to 0 kan, untuk both side kan.
Yeah.
Maksud saya both side tu untuk merah dengan biru kan. Kenapa dalam saya punya gambar rajah yang u du over dy tu nak equals to 0 lah? Sebab apa?
Oh, right. So ni daripada kelas first lah ni. Okay. Sekarang ni kita kena explain balik yang awal ni. Patah balik color merah lah. From what we did from the other day. Okay. You ada fixed plate. Okay. So you have limit dekat situ. Kita buka page lain lah. So you have fixed plate and fixed plate. And then you have top and bottom fixed plate. So lukisan ni dah tahu
Yes sir.
Okay, why it occurs like that. So you have your X and Y position. Okay. First when we do step number 1, remember? Step number 1 is draw the velocity profile. Then after that determine what is the velocity involved. Since our component is X, kan? Aminuddin. So velocity dia apa?
U.
Betul? Alright. So now U berubah terhadap apa? Del U over del Y kan? So U 0, 2, 4, 6, 4, 2, 0. Faham? 0 velocity, 2 velocity, 4 velocity, 2, 4, 6 maksimum, 4, 2, 0. So U berubah terhadap
Y.
Y. That's why del U over del Y tidak sama dengan 0. Okay, Aminuddin?
Okay.
So
Okay.
Betul So sekarang ini BC nombor 3. Pergi BC 3. BC 3 position dekat sini. Mungkin saya tak lukis kot. So BC 3 at that instant, at that point sahaja. At that point. So at that point, kalau untuk kes yang ni, merah. Untuk kes yang ni, height dia B lah. Height dia B. Okay, so BC 3. BC 3. Right. So ni BC 3 dah ni. BC 3. So at berapa? At Y equals to Aminuddin?
Y equals to B ke?
Y equals to
B over 2.
B over 2 ke? Sebab dah tengah-tengah kan? Sekarang maksud kita nak represent how we want to represent tengah-tengah, bukan represent the whole section. Yang ni maksudnya del U over del Y tak sama dengan 0, represent the whole section. 2, 4, 6, 4, 2, 0. Dia berubah terhadap Y. Okay. So when you put as Y equals to B over 2, so now how you want to represent the velocity at that particular point? Tengah-tengah tu lah. Okay. So at that particular point, U sama dengan U maximum betul?
Betul.
Ya. So sekarang ni U maximum U maksimum mudah.
Oh, okay, faham. Dapat. Okay, dapat. You maximum, lupa.
Boleh?
Boleh lupa you maximum kat situ.
So dia akan jadi apa?
Du over dy equals to
Sama
0.
dengan dia tak berubah.
Okay, sorry sir.
Tak apa. Okay. Ada lagi soalan? Okay, tak ada kalau tak ada saya proceed balik kepada yang atas ni. So I just want to point out the importance of origin, how they put out the axis. So position axis tu memainkan peranan penting. Contohlah, lagi diubah lagi kan. Kalau apa pula nak buat? Hopefully ada different terletak kat tengah pula. Tak. So sekarang BC1 akan jadi at Y equals to apa? Negatif B over 2. U sama dengan kosong. BC1. Negatif B over 2 and then U sama dengan kosong. Siapa boleh bagi saya BC2 yang atas? Y sama dengan
B over 2.
kan? Jadi positif betul tak?
Yeah.
Now at Y equals to B over 2, U sama dengan kosong. So how about BC3 pula? Siapa boleh bagi kat saya? At Y equals to berapa?
0.
Yeah. Y equals to 0. Del U over del Y sama dengan okay. Nurul Izzah Khairah. Faham? Ada soalan? Okay. Apa lagi? Muhammad Rashid.
Okay, sir.
Boleh?
Boleh.
Alhamdulillah. Sekarang ni, saya nak ubah lagi. Dah habis dah buku surat. Sekejap. Okay. Sama je, fit split. So sekarang ni, yang ini adalah what? Z, yang ini adalah X. Okay, so velocity sekarang dia dah Z Z tadi X, velocity adalah U. So Z sekarang dia akan jadi W. So del W over del X tak sama dengan kosong. Yang ni masih sama Fit split masih, dia punya velocity profile still looks like this. Okay. Okay, next lagi. Let's say kalau dia ubah lagi. Katalah dia ubah macam ni. Masih lagi fit split. So this is X, this is apa lagi? Y for example. Okay, so kat sini dia akan jadi negatif V. Okay, dia letak V dulu lah, V dulu. V dahulu. Okay, and then del V over del X tak sama dengan kosong. Tak sama dengan kosong. The change of V to X direction tak sama dengan kosong. So later bila you add Y tu, add X, katalah BC1 BC1, BC1, BC2. So BC1 add X equals to 0. So maksud BC kat situ lah. So V equals to negative V. Sebab V arah sana. So V tu yang you kena terbalikkan. Sebab Y direction arah kiri. Sedangkan V arah kanan. So sama juga. Sorry. Ni kosong lah sepatutnya. Kosong. Sorry. Kosong. V sama kosong. Cuma dekat BC3 ni. BC3. So add X equals to B over 2. Okay. Del V over del X. Del V over del X sama kosong. Okay. Cuma ni tak defect lah. Tak defect sangat sebab X kosong, V kosong. Okay. Del V over del X pun kosong. So bila masukkan equation kat situ mungkin tak defect lah. Okay, tapi you kena tahu V direction tu sebenarnya now negative V. So let's say if you have V value, you can masukkan negative value lah, okay, into the equation. Apa lagi? In terms of position, dia yang tak mungkin berlaku tak mungkin berlaku ataupun jarang. And then sepatutnya kita tak buat macam ni lah. Kalau you ada X and Y at a certain angle, direction of velocity in this direction, straight, horizontal, tetapi X and Y dia sengit kan. Boleh je nak bagi soalan macam tu, tapi sial lah kayu. Sebab dia kena leraikan kepada dua position lah. Okay. In X component, in Y component. Okay. Biasanya kita engineer, kita nak memudahkan kerja kita. Kalau kita sengitkan X and Y tu bermaksud kita dah plate tu kita sengit. Plate sengit. So tu maksudnya. So yang ni valid lah. So still, even though dia sengit, tapi kita letak axis kita pun sengit juga. So U masih lagi tak perlu leraikan, masih lagi sama macam tadi. Okay. So ada soalan? Tak ada
Tak ada sir.
Okay, kalau tak ada saya nak proceed lagi. So problem you fix plate. Now in terms of boundary condition. Okay. Okay, you dah pandai location ni. Betul? So sekarang ni kalau you ada flat plate. Okay, you ada free stream velocity. I believe I already explain this one. And then you pun dah pandai lukis saya rasa. So ni sama je lah. Free stream velocity. And if the flows over the flat plate, it become like this. Macam ni. Okay, bawah adalah surface roughness. So frictional effect to the left. So that's why dia jadi kosong. Atas adalah yang paling maksimum. Okay. So ni 10, 8, 6, 4, 2. So ni fixed plate. Okay, next. Contohlah diubah. You ada fixed plate. Kat bawah. And then you ada top plate. Moving to the right. Okay, cuba lukis. Macam mana bentuk dia punya velocity profile.
Sir. Sir,
Ya, saya. Ideal.
saya nak tanya, fluid flow ni ke arah kanan
Yang tu yang fit, yang atas dia bergerak kan. Ya, kat arah kanan.
Bolehkah saya assume yang moving plate tu dia punya dia punya velocity dia sama dengan fluid flow?
Ya, betul.
Oh, okay.
Yang atas tu sebenarnya akan jadi dia punya maximum velocity.
Yes, sir, thank you.
Okay. Okay. Alright, good question. Ideal ke adil? Okay. Kita tambahkan a little information on this part. Okay. So ni V lah. We don't know dia punya value. Dia just bagi simbol saja. So this is X, this is Y. So let's say bukan V lah kot. So X kita bagi large U. A certain value symbolized by large U. Now kita ada ke kanan and then ke kiri. So ni akan jadi U juga. And ni pun U juga. Macam mana bentuk velocity profile dia? Okay, so it means U 10 sama. Same U. Atas 10, bawah 10. Cuma direction dia berbeza. And then lukis juga. Kalau you ada this kind of problem. Now, when there is an effect of gravity. Okay. Air flows moving downward. Allah, pen ni kan. Fixed plate. Okay, and then you ada open. Okay, open system. Ini fixed plate open lah. There is no fixed plate. Ini open. Okay, Ashraf, Muhammad Ashraf.
Ya, saya.
Macam mana bentuk dia yang first tu? Bentuk velocity profile.
Sekejap, yang mana saya tadi saya?
Yang bawah fixed plate, atas yang plate bergerak ke kanan. Sebentuk dia macam mana?
Sama dengan yang atas yang saya.
Oh, dia tak boleh sama Ashraf. Cuba tengok Okay. Ish. Katalah plate yang atas dan yang bawah fixed plate. Okay. Sekarang ni tak bergerak Ashraf. Tak bergerak Atas ni walaupun plate tapi dia tak bergerak. Velocity dia kosong. So profile dia macam ni. Straight line. So sekarang ni bila dia bergerak, apa jadi? Dia punya profile. Mana Ashraf tadi?
Velocity profile dia
Bawah kosong. Betul. Atas
jadi atas jadi max kan?
okay. Atas jadi max. Betul. So bentuk dia macam mana? Awak bayangkan yang ni bergerak ke kanan. So bentuk dia starting dia straight line. Sekarang dia bergerak ke kanan. So, bentuk dia macam mana Ashraf?
Dia tak boleh straight kan sih?
Ya, starting dia straight lah. Atas, kalau atas fix, bawah fix. Starting dia straight betul bila tak ada air bergerak langsung. I mean fluid tu tidak bergerak, betul? So, sekarang kita gerakkan yang atas. So apa jadi dengan dia punya profile? Yang bawah ni saya nak bagi hint je. Saya nak bagi you hint saja yang ni. Sebenarnya yang ni lah. Bila fix dia tak bergerak, straight line. Tapi bila now dia dah bergerak ke kanan, dia akan jadi macam mana bentuk dia? Profile tu.
Saya tak tahu. Saya nak terang macam mana saya.
Oh ya ke? Alright, jadi segitiga je kan? Segitiga. Okay. Ashraf?
Betul lah saya. Saya nak jawab macam tu.
Cuma tak tahu nak terang Okay. Okay. So bentuk dia akan jadi macam ni lah. Okay, segitiga. So bila you bergerak ke kanan, so maximum velocity adalah yang jadi kat sini lah. Ke atas. Okay. So dia akan makin berkurang. Cuma dia akan jadi straight line Straight line. Segitiga straight. Jangan lukis segitiga macam ni. Sebab ini, curve ni adalah untuk something that is occurs naturally. For example, this one. This one adalah perbezaan P in and P out. Okay. Natural occurs. Plate tak bergerak. Yang ni pun sama. air movement, convective side. Air tu bergerak atas plate, nampaknya dia akan jadi curve line. Cuma untuk yang due to plate movement, kita akan lukis dia sebagai straight. Okay. So sama juga yang ni. So sama juga macam yang saya bagi dekat Ashraf tadi. Cara nak lukis biasanya kita start lah dengan initial point betul. Okay. Bayangkan plate atas, plate bawah tidak bergerak. So bila dia tidak bergerak, tu dah starting point dia. So now kita apply U ke kanan and then U ke kiri. So sekarang ni, yang ni akan berubah lah. So bila U ke kanan and then U ke kiri, magnitude dia sama. Straight line tadi sama macam ni. Kemudian akan meet kat center ke sini dan ke sana. Tu maksud dia. Okay. So dia akan center kat sini sebab U dia sama atas dan bawah. Ada center point. So please do imagine and practice this one lah. Okay. Sebab dalam exam dia tak lukis. For example this one, mana dia lukis? Bagi tahu. If you are not able to draw this from this, memang agak sukar lah you nak jawab. Meaning boundary condition pun dah silap kalau you salah kan. Okay. So idea dia adalah, the idea is basically, kalau saya lah kan, that's how I practice. Starting dengan straight line. Buat je straight line. Contoh macam ni kan. Straight line. So sekarang P in, P out. Ada perubahan pressure, so dia akan bergerak. So daripada situ, atas dia ada friction. Bawah pun ada friction. Dia punya maximum velocity kat tengah. Dia gabung je lah. Tapi kena bercurve. Dia curve sebab naturally occurs. Okay. Due to pressure, not due to movement of plate. Itu maksudnya. That's why saya always start dengan satu line yang kosong ni, tak bergerak. Okay. So sama juga yang ni. Dia sama saja macam yang this one, fixed plate. Cuma dia arah ke bawah. Okay, arah ke bawah. Macam ni lah. Ada curve juga. Okay, but for this case, gravity lah. Okay, the moment is due to gravitational effect. Next, kita ada fixed plate. Okay, fixed plate juga. Fixed plate. And then fixed plate. Okay. So the same like fixed plate tadi. Cuma dia macam ni lah. Ke bawah. Okay. And then let's say you ada pressure difference P in and P out. Yang bertutup, sistem yang bertutup memang akan ada pressure difference. You tak boleh cancelkan. Cuma yang open saja you boleh cancel dia punya pressure difference. Ini open system ada segitiga ni. Okay. And then untuk yang case yang belah kanan ni, okay, P in and P out is the effect due to movement plus the gravity. Okay, gravity. So let's say kalau tak ada gravity kalau tak ada gravity, mungkin macam ni lah. Pressure difference saja. Mungkin tinggi ni saja dia punya maximum velocity. Tapi since dia ke bawah, Ada dua-dua. Pressure in, pressure out, and plus D, gravity. Dia tambah lagi ke bawah. Tapi tak perlu lukis lah, tak perlu lukis. So just kena faham lah. Ada dua effect. One is pressure difference, another one is gravitational effect. Pressure difference maybe piping ni datang daripada tank, for example. You ada water tank kat atas kan. Water tank, ada pipe, combine dengan ni. So that's why akan ada pressure difference. Bila dia bertutup. Okay. Faham semua?
Faham, sir.
Okay, kalau faham, kita rehat dulu sekejap. 5 minit. Bagi Chan dulu kan. Compress sangat ni. Okay. Rehat. Sekejap lagi dalam 9.35 kita masuk balik. Okay, so kita sambung balik Right, sambung semula. Okay, we are going to continue a little bit. I just want to explain some of the example of question. So I just put it on the WhatsApp group April 2008 punya soalan. Alright, semua boleh nampak? Nampak tak? Tanya presentation.
Nampak sir.
Okay, alright. So kalau tengok yang ni adalah macam saya explain tadi lah. Okay, segitiga ni bermaksud pressure sama saja. Okay. Now movement is due to gravity. Kalau tak ada gravity tak bergerak lah. Okay. Pressure tak ada sebab pressure dia sama. Okay. This is second question, second example. Okay. Just want to point out to you, solution dia sama sahaja macam yang sebelum ini. Okay. Tengok dia ada reduce the 3-dimensional Navier-Stokes. Okay, kena buat assumption. And then dia akan jadi 1D dimension lah. 1-dimensional problem. And then kena letak assumption. Okay. So untuk chapter ni, soalan Navier-Stokes ni, step yang saya ajar tu, you repeat saja. Cuma berbeza soalan. Different kind of question. Tengok ni, the direction of flow. Y, and Z. Before this, X and Y. But here now, Y and Z. So the flow will be W lah. W. Okay. Number 1, number 2, and number 3. Take a look at number 3. Find the vertical Z direction velocity profile. Okay. So it means they want expression. Obvious because they don't put in any kind of value here. There is no mu value, density value. Okay, it means they want expression. Okay, always like that, expression. Okay, if they ask for value, they will ask for calculate. Calculate apa lagi? Calculate, analyze. Biasanya calculate lah. Okay, must be calculate lah for you to get the actual value. Okay, so nak explain ni, non-slip boundary condition. So what it means by non-slip boundary condition at the wall, okay, non-slip boundary condition at the wall, it means whatever happened with the wall, that is what happened to the fluid. Okay, let's say if the wall fixed, so it means the velocity should be 0, the fluid velocity. If the wall is moving at a certain velocity u, 10 meter per second, so it means the velocity at that wall is 10 meter per second. Kalau ada slip boundary condition, plate moving 10, wall tu moving 8. Nah, itu maksud dia. If there is a slip boundary condition, but here non-slip boundary condition. So whatever happened with the wall, that is what happened to the fluid. Okay. Negligible shear at the face. Macam first time tengok je kan. Negligible shear at the free space. Pula dah. Sedangkan ianya bermaksud del U over del Y sama dengan kosong. Yang kita buat tadi. Del U over del Y. Del U over del Y itu adalah shear. Negligible shear sama dengan kosong. So kadang-kadang you ingat saya tak ajar kan, padahal sebenarnya semua benda yang sama saja, cuma term sajalah yang digunakan dalam soalan exam. Okay, alright, so you can try to do this question on your own, okay, and discuss. I will give the final answer later. Okay, ada soalan untuk yang soalan yang ini? Okay, tak ada. Okay, tak ada. You're gonna go for Navier-Stokes. Oh, still Navier-Stokes, but Instead of Cartesian coordinates, I'm going to go for cylindrical coordinates. Okay. Right. Cartesian coordinates is in terms of x, y, and z. Okay. Right. But for cylindrical coordinates, this is for cylinder. Okay. So you have z direction, and then you have your r radial direction, and then you have your theta angular motion or angular direction. So r, z, and theta. Okay. So you have three components as well: radial component, tangential component, and axial component. Okay. So the step involved will be the same. Will be the same like what we did before for Cartesian coordinates. Okay. In fact, the equation also similar. So this is for convective part. Alright, convective part. And this one is for okay, pressure difference. And this is for gravitational effect. And this is for shearing. Shear. Okay. Right. Now take a look at the equation itself. Okay. The equation is the same. Okay, you have steady, unsteady, steady term. Okay. So like what we have before is what del u over del x. This is del u over del t plus u plus v plus w. So you have del u over del x, del u over del y, del u over del z, right? And then you have del p over del x, and then plus the mu, okay, or the shear plus rho g x, okay. So if you notice u, this is for x component. So for our case here is z, theta, and r lah, okay. So for u now, everything become, for z now, everything become vz, v, vz. Doesn't matter. Some book put it as uz, but the thing is, they can use anything, but then the thing is subscript to must be z. So vz, 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 del p over del z, vz, vz, vz. Okay. Now you have your unsteady term. Okay, and then you have your v. I always refer back to the Cartesian coordinates for me to understand what is the equation for spherical coordinates. That's what I practice. Okay, so for u is actually this one r lah, radial component u r. Okay, this one is actually for theta. This one is actually for z. So untuk for Cartesian coordinates u, v, and w. So this one is r, z, r, theta, and z. Okay. Next is x component. And after that, they change to y component and they change to z component. Now here, they change to r component, change to theta component, and change to z component. So the same, no different. And here is del p over del z. For this case, almost the same. Okay. This is del p over del x. Del p over del x. For this case, is z component del p over del z. Okay, now is this one is second order. Remember, del squared u over del x squared plus del squared u over del y squared, and then del squared u over del z squared. So for our case, nampak tu, del over del r, second order. But the thing is, due to what derivation, they're still left with some part of the equation, 1 over r, r. Okay, But the thing is, don't be afraid. Ini adalah second order untuk R component. Del squared del X squared. Del squared del X squared. Untuk R component 1 over R del over del R, R del over del R. So kita tengok dia akan repeat balik ke atas. Sama je kan. Okay. So sama juga dengan ni 1 over R squared del squared over del phi squared. This is for theta. Sometimes sebut phi but theta. Del squared over del theta squared. And del squared over del z squared. Okay. And repeat again untuk this one. Okay. Del squared over del z squared. Cuma untuk bahagian tangential component ni, due to some derivation, dia ada penambahan sikit. Yang ni adalah untuk z squared. Okay. Kemudian ada bahagian yang ini. Okay. Okay. For this one is gravitational effect. Sama saja. Rho G. Rho G. Okay. Any question on cylindrical coordinates? Never stood for cylindrical coordinates. Okay, saya dah post attendance dekat chat. Minta tolong isi. So bagi you seminit untuk isi sekarang. You have pipe, right? And then the fluid is actually in between the road and pipe. In between. So this is pipe. And this one is road. Okay. So when you have this case, this kind of fluid flow, one part of it solid and there is a fluid in between another pipe tengah tu, okay, kita panggil dia sebagai annular space. We call them as annular space. Why that statement is important? Okay, that particular sentence is important because sometimes dia tak lukis pun. Dia tak lukis pipe atau apa-apa saja, dia tak lukis. So, imagine there's no, ditutup gambar raja tu, you baca. A Newtonian fluid flows in an annular space created by concentric pipe. So, you dah kena bayang, if they put out as annular space, dia adalah fluid in between two pipes. One of them is solid, another one is hollow. Okay. So now the rod is moving in a constant velocity v. So Vz, constant velocity v. So this one is R. So the first part of this step is to draw the velocity profile. So atas fixed, pipe is not moving, only the road is moving. So the drawing should be like this. Segitiga juga. Tak boleh ada curve because of the movement of fluid is due to movement of the road. The plate. Kalau contoh atas tadi plate lah. Now it's actually road. Okay, so you are gonna have two boundary conditions. At the top and other bottom boundary condition. Okay. Alright. So now you have Z direction and you have R. So it means the change of velocity del Vz over del R is not equals to 0. Okay. Kat sini ada apa? 10, 8, 6, 4, 2, 0. So 10, 8, 6, 2, 4, 6, 0 ni, 6, 4, 0 ni adalah berubah velocity, arah, R direction. So that's why del Vz over del R is not equals to 0. Okay. Next is what? Since you already know your problems is only VZ, okay? So it means radial component cancel, theta component also cancel. Because of what? Everything is VR, 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 VR sampai hujung. And this one is V theta, V theta, V theta sampai hujung. Kita hanya ada VZ. So only this part left. Reduce the Navier-Stokes equation. But for this case, it's cylindrical coordinates. Okay. Next is assumption. Assumption, like before, ada 4 kan assumption. Or sometimes kalau you nak letak 6 pun tak apa. Include sekali dengan pressure as well as gravitational effect. So number 1, steady flow. So it means del over del T equals to 0. Number 2, VZ. So it means no flow in R direction. Number 3, no flow in theta direction. Number 4, fully developed. Laminar flow. Okay. So fully developed laminar flow is actually del VZ over del Z sama dengan kosong. Okay. Because of segitiga. So dia kalau pipe ni panjang kan. The pipe is actually panjang. Segitiga dia bentuk dia sama saja. It's no different. So it means arah Z direction, arah pipe kosong, tidak berubah. The change of velocity on Z is equals to 0. That is the words of that particular equation. Or equation lah. Del VZ over del Z equals to 0. Okay. So after you done the assumption, and then the next part is to solve the continuity equation. Okay. So I'm gonna give you, give me a second. The attachment.
Saya explain ke?
Alamak, saya tutup ke? Okay. Okay, saya ulang balik. So dalam ni, ni lah appendix yang dia bagi. Appendix bagi. So you ada continuity and then Navier-Stokes equation untuk Cartesian coordinates as well as for cylindrical coordinates. So do not worry, tak payah hafal. Hopefully dia akan terus bagi. Biasanya ya lah, kalau tidak kejam lah tak bagi banyak sangat ni. Okay, and then the next part is actually yang tadi for the question for cylindrical coordinates is actually you need to solve continuity equation before you solve for z component. You solve lah. Okay, so later I'm gonna give you this appendix to the WhatsApp group, and then from that you can refer which equation is given in there. Okay. Alright. So kalau tak ada soalan, attendance hopefully semua dah isi. Baru 23 orang ni. Yang lain sebab isi sekarang. Attendance. Ada soalan sambil-sambil tu? Okay, so kalau tak ada soalan, kita akan continue next class on Thursday pukul 8. Okay, so I'll see you in the next class. We end our session with Ustaz Biki Farah and Sarawak.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Alright.
So,
Assalamualaikum.
Thank you, sir.
Thank you, sir.